Let's talk about static data members. Normally, every object of the class has its own copy of member variables. But sometimes we want one common variable that is shared among all the future objects. For example, to count how many objects have been created. So suppose we have a class, say employee, and we want to keep track of how many employees have been created. We might be tempted to add a regular integer variable called maybe count inside the class, but here's the issue. When we create multiple objects, each one gets its own copy of that count variable. That means, for example, I have multiple objects created for the employee class, E1, E2 and E3. That means E1 has one count, E2 has another, and E3 has its own. So they do not share a common value. So if I try to increment count in one object, the other objects do not get updated because they have their separate versions or copies of that object. So the total count will always stay incorrect. Each copy only knows its own version. So to fix this problem, we might think of using an external variable outside the class, like sort of global variable, but then we can lose encapsulation as the data no longer controlled by the class itself. Alternatively, we can create an initialization function or an update function that keeps the track manually. But that would mean remembering to call it every time the object is created, and this is also an error-prone approach. What we really need is a variable that's the part of the class, but it is shared among all its objects, something that exists only once, no matter how many objects of the class you create. That's exactly where static data members serve the purpose. To do this, we use the keyword static when declaring the variable inside the class. A static member belongs to the class itself, not to a specific object, so it is class level. Static member variable belongs to the class as a whole, not to any one object. Every object can access it, and when one changes it, the change is reflected for all the objects. So next we will look how to declare a static data member, define it properly outside the class, and see how multiple objects share the same value automatically. Let's look at how to declare a static data member. So when we create three employees, E1, E2 and E3, there is only one copy of count shared by all of them. Every time we call the member function setData, it increments the same shared counter. Notice how we define the static member outside the class using that scope resolution operator. So this step is mandatory. It allocates the storage for that variable. So you write a data type int, then a class name employee, then scope resolution operator, then the name of a variable, that is count in this case, and then you initialize also at that place. So when we display the data, even though the count is used by each object, all three show the same cumulative value, proving that the count is shared. In addition to static data members, we can also have static member functions. These functions operate at the class level again rather than the object level. So static functions are declared with the keyword static, and they can be called directly using the class name. So we do not need to create any object. So here show count is a static function. It accesses the shared variable named box count, which keeps track of how many objects of box have been created. So static members and static functions are a great way to manage the data and behavior that should be common across all the instances of the class. Now here's an important rule about static member functions. They can only access static variables of the class. Let's see why. This is because the static function doesn't belong to any specific object, it belongs to the class itself. Since it is not called through an object, it doesn't have access to instance variables. So there is no this pointer available. We will see this pointer in a moment. So inside a static function, we can only use other static members not the regular data members of our individual objects. This is another example of race car class, and we aim to add or have a cumulative count of how many cars have been added in the game of race cars maybe. So we need to define a static variable for counting the number of cars. We named it num of cars, and for demonstration we have added another variable that is non-static, that is not static, named. So this is a regular data member, not a static one. So now let's look at a static function. So as I already explained the rule, so static functions can only access the static members. So when we write cout num of cars, it doesn't show an error. When I try to write or access score variable, so since static function can only access static members, so this will throw an error. Then then you can also see the function below, that is non-static. So this is a regular member function, non-static function. So in this you can access both the non-static and static data members. So the rules applies only on static member functions.